Hello everyone, welcome to the structural design and drawing lecture class. In this class, we'll see about Unit 1 introduction. So Unit 1 topic is retaining wall and we'll see in detail about the designing of retaining wall. Okay. So the first question that comes to your mind is what is retaining wall? Right? So the name itself infers that retaining wall, the retains means it holds something from the structure. Okay, so retaining wall is a type of structure. It is designed in such a way that it withstands lateral pressure. So in this purpose of the retaining wall is to withstand lateral pressure that is caused by the soil or the soil material. Okay. Next slide, we'll see about the proper definition of what is retaining wall. So you can see in the slide. So retaining wall, as I said before, it is a type of structure which is designed and constructed to withstand a lateral pressure of soil or soil material. So in general, it is a structure to support earth material. Okay, it can be the earth material, can be a loose stone or any other material which cannot stand by its own vertical support, which cannot stand vertically unsupported. So we need to support it to bear the pressure from the lateral. Okay. So this lateral pressure would be either earth filling or a liquid pressure or any other granular material which stands behind the retaining wall structure. Okay, so we have different applications of retaining wall. It is used on several places. Mainly, it has been constructed on the basement of floor, subways, bridge abutments, and box culvert. So you can observe these type of structure. That is, you can observe retaining wall in these applications, mainly in your box culvert and bridge abutments. Okay. Next, we move on to the different types of retaining wall. Okay, so we have some basic major divisions of retaining wall. So in this first unit, you will be mainly focusing on design aspects of two particular types of retaining wall. Okay, so those are, one is cantilever retaining wall and counterfort retaining wall. So before getting into the design part, so we'll understand what are the different types of retaining wall is there. Okay, so first one is the flexible wall method. The name, you can flexible, the wall is flexible. So how it is being flexible? If it is, the member is very slender. Okay, slender means if it is long, that is the length is more when compared to width. We call the member as slender, right? So this long slender member, which is either made of steel, concrete, or wood. Okay, so they rely on soil resistant, and since it is very slender, the member is anchored. Okay, anchored means it is fixed at one end. I'll show you the picture of flexible wall in the next slide. So where do we use flexible wall? So it is used in waterfront construction structures or temporary structure for excavation. Since it is flexible, you cannot use it as a permanent structure. It is used as a temporary structure in the case of excavation. Okay, so I'll show you the picture how the flexible wall is done. Okay. So you can see here in flexible wall, we have cantilever, anchored or tie back, or next one is propped. So in the cantilever, you can observe this is the wall, this line, the vertical member is wall. Okay, we have soil at this horizontal member and we have soil at this portion also. Okay, so this is nothing but your cantilever, and this cantilever is anchored. If some external support is provided or balanced the slender member, we call it as anchored or tie back member. Otherwise, the third type we have is propped member. So propped is done on the the passive earth pressure. So we'll see what is passive earth pressure and active earth pressure when we move further on the lecture classes. Okay. Is that clear? So this is first type is your flexible wall. Okay, in flexible wall, we have cantilever, anchored, tied back, or propped. Okay, so this tells you about the same, about the anchored rod or anchored block. And the second picture shows you about the struck member. And the second type is a rigid wall. First one is we discussed about flexible wall, and second type is rigid. So in rigid means the wall is very hard. Okay. So rigid wall, we have further subdivision. We have cantilever wall, cantilever retaining wall, gravity, and counterfort, and etc. Okay. So rigid itself, it is hard. So usual material made up of is made up of plain concrete. Okay, your rigid wall is mainly made up of plain concrete. So the entire stability is attained by its own weight itself. Okay, by its weight, dead weight. That is nothing but your self weight. Whereas in the case of flexible, the stability is achieved by anchoring. Okay, whereas in this case, the stability is achieved by dead weight. Okay, so dimension is also proportionate so that it doesn't create any tension at base. Okay, so we know concrete is good in compression and weakens tension, right? So to overcome that, we design such a way that we dimension it, we give it up the length, breadth, and the height of the member in such a way that it doesn't create any tension in the base. Okay, so usually if you see gravity retaining wall, the height is up to only 3 meters. Okay, it doesn't goes up more than, if it goes more than 3 meters, it's found to be uneconomical section. Okay, so uneconomical, I mean the cost wise it is more when it goes up to more than 3 meters. If it is less than or up to 3 meters, the section is to be economical, and it means, I mean, the cost wise it is effective. Okay, I make sense. I think you get the point now. Okay, so in gravity wall itself, we have further subdivision. We have solid gravity wall, another one we have it as semi-gravity wall. Okay. So you can see what is gravity. You can see from this picture. You have gravity wall, semi-gravity, and cantilever gravity wall. Okay, so gravity wall, we have solid. Entire thing is filled by your concrete member alone. Whereas semi-gravity, we have reinforcement is also provided, and reinforcement is embedded in your concrete member. So cantilever wall is comparatively slender when compared to gravity and semi-gravity. Okay, we have reinforcement at your slab and we have reinforcement at your basement also. Okay. So next type we'll see in detail about cantilever retaining wall under rigid wall. Okay, we have two major subdivision. One is flexible wall, other one is rigid. And flexible we have propped, cantilever, and anchor. In rigid, we have gravity wall and cantilever retaining wall and further. Okay. So in cantilever retaining wall purpose is more commonly is more than 3 meter height. If you want to provide a cantilever, if you want to provide a retaining wall more than 3 meter, cantilever retaining wall is suggested. Okay. And if you consider cantilever retaining wall, it consists of 3 major parts. One is your stem, okay. One is the stem, heel, and the toe part. Okay, it is construction of cantilever retaining wall. It can be either reinforced concrete or a precast member or pre-stressed member. Okay, reinforced concrete means you have concrete and reinforcement. Precast concrete means it is the concrete member has been cast away from your construction site. Okay, from construction site or some casting yard, the the concrete member is transmitted to your construction site. That is your precast member. In pre-stressed member, the member is stressed initially so that when it can be able to counteract the load when it is applied. Okay, so that is the construction methodology of your cantilever retaining wall. So if you consider two major types of cantilever retaining wall available, one is inverted T and other one is L shape. Okay, so if in L shape you can see there is no toe projection. So I'll tell you what is heel, toe, and stem. Okay. So you can see here the cantilever retaining wall. So in the picture, the first picture tells you about the cantilever. The second one is your L-shaped cantilever. Okay, the retaining wall is adopted when the height of the fill is less than 6 meters on the basis of economy. Okay. And the third type, we have counterfort retaining wall. So in counterfort retaining wall is majorly designed as and strengthened with the counterfort. Okay, counterfort is similar to cantilever, and the additional strength is provided with the help of counterfort, which is cast monolithically in the back of the wall slab. Okay, so counterfort is in tension so that it will be able to reduce bending and shear stress. Okay, so what is bending and shear stress? Right, the bending is happening because of your external load. Shear is happening at your support because of your external load. Okay, the stress is, how do you calculate stress? That is nothing but your load by area. That is a load applied at the particular area. Okay, so this counterfort is placed at the regular interval, and the spacing is usually equal or slightly larger than the height of your counterfort. Okay, the spacing of counterfort is slightly equal or larger than the height of the counterfort height. Okay, it acts, as I said, the counterfort is tension. It is a tension stiffener member. Okay, so in this slide you can see what is counterfort. It is similar to cantilever retaining wall. You can observe a counterfort member. Okay, now additional support is provided at your stem wall. Okay, so this portion is called as stem. This portion is called as your toe, and this is your heel. So you can remember your feet. Okay, so feet has two parts. Okay, on the heel part is the where the load is maximum, and the toe is the where your fingers are pressed. So smaller portion is your toe and larger portion is your heel. The vertical member we call it as a stem. Okay, so this additional member, the counterfort, so this acts as a tension stiffener. So it is great to withstand tension. So this counterfort is placed, spacing of counterfort between from one to the other is slightly larger than the height of your counterfort. You can see the height of the counterfort. Okay, is that clear? So we'll move on to the next one. Next one is the buttressed wall. So buttress is in front member. Okay, so it is much similar to counterfort. So buttress is in the compression zone. Okay, so since in the front on the elevation part of your counterfort, it makes the look weight not aesthetic. So advantage, if you look upon the advantages of your buttressed wall, it is economical and good for some if it is low rise earthwork. Okay, and it is also used for the architectural basis. So this is a summarize of your types of retaining wall. We have gravity retaining wall, T-shaped retaining wall, L-shaped retaining wall. Okay, we have counterfort, buttress. Buttress is you can have it as an inverse of counterfort. So this side we have active earth pressure, and this side we have passive earth pressure. So when the earth fill is more, we have active. Okay, so if the buttress is lying on the outside of your retaining wall, we have buttress retaining wall. So this portion tells you the plan of the counterfort, and this is the plan of your buttress retaining wall. Okay. So we'll move on to the basic terminologies of the retaining wall. Okay. So this picture tells you about the some basic terms that will be associated in detail about the designing and detailing of your retaining wall. So okay. So we'll move from bottom to top. Okay. So we have as I said, if you remember the feet, human feet, we have toe and heel. Similar to that, the feet of the retaining wall, the base. Okay, base slab is divided into two. One is toe, another one is heel. Okay, the toe is always a smaller portion. The heel is always a larger. I mean, in the larger in the lengthwise. Okay, so this side we have backfill. Okay, so this backfill has to be retained by the your retaining wall. Okay, so that backfill can be either liquid, earth, or any other material. Okay, so and some quantity of backfill is also available above your toe. Okay, so this vertical portion is nothing but your stem. So three basic terms you have to remember in unit 1 is your designing of stem, designing of toe, designing of heel. Okay. In addition that we have front face, we have rear face. That is the rear face is a back face. Okay. And we have drainage hole is also provided so that the water from the backfill can be drained easily. Okay. And subcharge is nothing but the weight above the backfill. Okay. So weight above the backfill. So this each terms are explained. The backfill is nothing but the material that has to be retained. We call it as backfill. And the angle of repose, we have the angle of repose, the term you have very much similar. You have learned in detail in soil mechanics. Okay. So the backfill, when it is unsupported, okay, it attains some natural slope. So when slope is there always there is an angle. Okay. So with respect to horizontal, it makes an angle. Okay. So if the soil slope is less than pi, okay, if it's less than angle of repose, it will be stable. If it's more than the angle of repose, it will be unstable and it tries to collapse easily. Okay, that is about your angle of repose. Okay, so these are the factors influencing your lateral pressure. So as I said, some pressure elements are being affected or influenced in the lateral pressure. That is nothing but your type of backfill, that what material of backfill is there. Next one, the height of the backfill. Okay, at what height the backfilling is done, and the condition of the backfill, either it is dry, moisture, or semi-dry, or it is submerged. Okay. And the last last topic of the introduction part is the forces acting on the retaining wall. Okay, so two different types of forces are, one is lateral pressure, another one is gravity load. Okay, so the lateral pressure is mainly because of the soil material or the earth material that is present on the back face of the retaining wall. Okay, the gravity load is nothing but the self weight of the member. So, okay, so gravity always acts downwards. Okay, and the subcharge weight is also considered under your gravity load. Okay, is that clear? So in this class, we have discussed in detail what is retaining wall, where it has been applied, and what are the different types of retaining wall available. Okay, so we have two major categories. That is, one is flexible and rigid. Under flexible, we have cantilever, prop, and anchor. Under rigid category, we have cantilever, counterfort, and gravity retaining wall. Okay, so and we have discussed about what are the basic terminologies involved and the forces acting in the cantilever retaining wall. Okay, I think you got an idea about what is cantilever retaining wall, what is retaining wall, and where it is used. Okay, so we will see in further classes. Thank you.